Today's topic is the number system. Let's start with our old friend, the number line. On the number line, there are positive integers such as 1, 2, 3, and so on. And these are called natural numbers denoted by n. There is also 0, and set of 0 and all the positive integers is denoted by w. Now there are negative integers as well, -1, -2, -3, and so on. And a set of all the negative integers, the positive integers, and 0 is denoted by z, or the set of integers. So there is n, which is a set of natural numbers which includes all the positive integers, does not include 0. W, the set of all the positive integers plus 0, or set of whole numbers, and z, the set of integers. But there is more. Let's look at the expansion of the numbers between just two integers, 0 and 1. Between 0 and 1 there is 1/2. Between 0 and 1/2 there is 1/4, and between half and 1 there is 3/4. This set of all such integers plus quotients which are can be represented as p over q, where q is not equal to 0, is denoted by a set. Again, there are more numbers here and more numbers here, negative ones. That is denoted by the symbol q, or quotients. So an important thing to look at is q is not equal to 0. So you can represent them as p over q, and q is not equal to 0. Another point is there are multiple such representations. So 1/2 can be represented as 2 over 4, or also 10 over 20, and there are many more such representations. But typically we consider the representation where there are no common factors. There is a common factor of 2 in the second representation, and there is a common factor of 10 in this third representation. So typically 1/2 is so-called canonical representation of this particular quotient that we consider. Now let's consider the problem of, given any two integers, how do we find more rational numbers between the two. The set of q quotients is also called as rational numbers, by the way. So let's say that we want to find out 3 rational numbers between 1 and 2. So an easy trick is, first let's add 1 and 2 together, so that will be 3. So 3 divided by 2, that's the average of 1 and 2. That is going to be a rational number that's between 1 and 2. And repeat the same trick again. So 1 plus 3 by 2 will be 4 plus 3 by 2, that will be 7 by 2. Again, so it will be like this: 1 plus 3 over 2 equal to 2 over 2 plus 3 over 2, and you add it will be 5 over 2. Okay, there's a mistake here. Mistakes are common in mathematics, you just need to know how to correct them. So we have 5 over 2 over here, and there will be 7 over 2 over here. So these are the 3 rational numbers between 1 and 2. So this is method 1, right? So simply method 1 is basically you just keep on finding numbers one by one by finding the midpoint between two numbers that are already there. Now there is also another method. Just for simplicity, let's call it method 2. And in this method you find all the rational numbers at once. Now let's state example again. In the number line you have 1 and 2, and you want to find out 3 rational numbers between these two. So what we'll do is take 3 plus 1 equal to 4 as the denominator, and represent 1 and 2 with that denominator. So 1 is 4 by 4 and 2 is 8 over 4. Now any of these, right, so 5 over 4, 6 over 4 and 7 over 4. 6 over 4 is same as 3 over 2, since 2 is a common factor. So these three integers, or sorry, these three rational numbers are between 1 and 2, and in this method, like, you find them all at once instead of proceeding one by one. So you can use any of these methods to find any number of rational numbers between two integers. Now the next topic is, we found that we know how to find these rational numbers, or any number of them between two integers, but is that all there on the number line? The answer is no. There are irrational numbers as well, and that will be the topic of next session. Thank you.